Okay, this last chapter is about queuing analysis. So content for this chapter includes elements of waiting lines analysis. So elements, it means that what are things that involve in waiting line analysis. Single server waiting line. So in queuing system, we have two types of arrangement servers. First is single server and secondly is multiple server. Okay, so and then next is the characteristic of service time. So we have two types of service times. First is undefined and second is constant. And then another characteristic is this is operator characteristics. So it means that the performance measurement that we are measuring. Okay, finite queue length, finite calling problems. Okay, and then another section is about addition types of queuing systems. Okay, so for queuing analysis, as I mentioned in the last lecture, there are significant amount of time people might spend in waiting lines, either people or product, parts and so on. So providing quick service is an important aspect of quality customer service. So this is the performance measurement that we are measuring, which is to provide quick service. So what are arrangements or input that we can provide so that we will be able to get a quick service. Okay. So basis for waiting line analysis is the trade-off between the cost of improving service and the cost associated with making customers wait. So these are the measurement for the decision maker to make. It's either the cost of improving service tolerable and compare with the cost that make the customer wait. So this is how the decision maker make decisions when we present to them the arrangements of queuing units. Okay, queuing analysis is a probabilistic form of analysis. It means that all the parameters involved in queuing systems are probabilistic type of data. And this involves probability distribution. The results are referred to as operating characteristics. It means that all the performance measurement that we measure are called operating characteristics. For example, number of people or products waiting in queue or waiting in the systems, average number of people in queue, utilization, waiting time, waiting in the time in the system, waiting time in line, and so on. So these are called operating characteristics. So the result presented to managers will be provide as basis for them to make decisions. Okay. Okay, elements of waiting line analysis. Waiting line form because people or things arrive at a first service faster than they can be served. So this is the things that make waiting lines become longer and longer because people or things arrive at a service faster than they can be served. So this make congested. The place become congested. Okay. Most operations have sufficient server capacity to handle customers in the long run. Customers, however, do not arrive at a constant rate, nor are they served in an equal amount of time. This is very common because people arrive are not constant. Some arrive maybe for 1 hour, maybe 10 people arrive. For the next 1 hour, maybe fewer people arrive, let's say 5, and the following hour, maybe more than 10 arrive. So it is not constant. Okay, so waiting lines are continually increasing and decreasing in length and approach an average rate of customer arrivals and an average service time in the long run. So when customer become long in queue, so this increase the waiting lines. Okay, decisions concerning the management of waiting lines are based on this average for customer arrivals and service time. They are used in formula to compute operating characteristic of the system, which is in turn form the basis decision making. So all these operating characteristics will be given in the form of formula. So we need to identify what are parameters involved and then use the formula to calculate the unit or the measurement for the operating characteristics. Okay, so this is element of waiting line in single server. We have service facility and we have customer waiting in line. Okay, so factors to consider in this environment or in this system are queue discipline, nature of the calling population, arrival rate and service rate. Nature of the calling population means that in this arrangement we have a first come first serve. Whoever come will be served first. Okay, so there are a number of calling population types like last come, first serve, and so on. Okay, so these are important factors to be considered in analyzing a queuing system. Okay, for single server components, for queue disciplines means that the order in which waiting customers are served, such as first come first serve, that are very common arrangement of queue discipline. Calling population means that whether we consider the infinite or finite number of people or customers involved in the queuing system. So the calling population can be either infinite or finite. Okay, arrival rate means that the frequency at which customer arrive at the waiting line according to a probability distribution. Normally, arrival rate use Poisson distribution because it is discrete. Okay, for service rate, is the average number of customers can be served during a time period. It is often described by the negative exponential distribution. Okay, if the service time are given, if the input given as service time, so we need to calculate the service rate. Okay, service rate is given by 1 over service time because it is an inverse of service time. Okay, so for single server, these are assumptions that we make for basic single server. We have an infinite calling population, first come first serve discipline, Poisson arrival for arrival rate, and exponential service time for service time. Okay, these are two important probability distribution. For arrival rate, we use Poisson probability distribution. For service time, we use exponential probability distribution. Okay, so this is symbol used for arrival rate, which is lambda, and for service rate, we use mu. Okay, these are important properties that we need to follow. Customers must be served faster than they arrive, which is lambda must always be less than mu. Okay, otherwise, infinite large queue will build up. Okay, so these are basic formula for single server queuing. Okay, probability that there is no customers on the queuing system is given by P0, which is 1 over lambda over mu. Once lambda and mu are given, so we need to calculate P0, which is probability that no customers are in the queuing system. Okay, for probability that n customer in the queuing system, we have Pn. Pn given by lambda over mu power n time P0. Okay. Okay, next is operating characteristic is average number of customers in system. For average number of customer system given by L, which is lambda over mu minus lambda, and average number of customers in waiting line given by LQ, given by this formula. Average number of customers in system meaning that the number of customers queuing and also number of customers being served. Okay, for number of customers in waiting line is considered only number of customers wait in line except the one the exemption that the one being served is not included. Okay. Okay. Another operating characteristic is average time customers spend waiting and being served, given by this formula. Okay. Another one is average time customers spends waiting in queue, given by this formula. And probability that server is busy is utilization. Okay, utilization is probability that server is busy, given by lambda over mu. Probability that server is idle is an opposite of probability server is busy, meaning that 1 over mu or 1 minus lambda over mu. Okay, example. Single server waiting line system. Given lambda arrival rate is 24 customer per hour and service rate is 30 customer per hour. So in order to find probability that no customer in the system, just substitute the formula lambda 24 and mu 30 in the formula. So we have there are 0.2 probability no customer in system. Okay, average number of customer in the system given by L, lambda mu over lambda given by 4 customers in the system. LQ is customers in the waiting line given by this formula, which is 3.2. And then average waiting time given by 10 minutes. Average waiting time in line, this is W is waiting line in the system, meaning the including the one in being served. Okay, WQ do not include the one being served, only in the line. Okay, only in the queuing line, given by 8 minutes. For utilization, lambda over mu is 0.8 probability or 80%, and server is idle is 1 minus 0.8, which is 20% or 0.2. Okay, because of steady state nature operating characteristic, utilization mu must be less than 1 or lambda over mu must be less than 1. This is the condition that we need to fulfill. Okay, we need to have these properties. The ratio of the arrival rate to the service rate must be less than 1 or service rate must be greater than the arrival rate. Server must be able to serve customer faster than the arrival rate in the long run, or waiting line will grow to infinite size. Okay, so now we have this example. Let's say the manager wish to test several alternatives for reducing customer waiting time. Addition of another employee to pick up purchases or addition of another checkout counter. So they have 2 options. So they want to decide which option are the best. Okay, alternative 1, addition of employee will raise the service rate from 30 to 40 customers per hour, and cost is 150 per week if we have for the first option. This avoid loss of 75 ringgit per week for each minute of reduced customer waiting time. So, given these parameters, we substitute in the formula given. So we have this value for the operating characteristic. Okay, so now average customer waiting time is reduced from 8 to 2.25 and worth 431.25. Okay, because we have 75 ringgit per week, so therefore if it is reduced to 2.25, so we multiply by this value and it is saved by 431.25. And then minus the cost per week 150, so we are able to save this cost. Okay, if we have the first option. Okay, now we look at the second option. Okay, for second option, if we were to build a new checkout counter, which is 6,000 plus 200 per week of additional cashier, we have a new arrival rate, which is divided by 2, since we have 2 lines. Okay, 12 customer per hour and mu remain the same. Okay, each counter will remain the same service rate, which is 30. And then we insert into the same formula and be able to get this value for operating characteristic. So here we can see that we save from reduced waiting time worth 500 per week, minus 200 per week for additional cashier. So you are able to save about 300 ringgit per week. And then after 6,000 is recovered from building a new checkout counter, so we are able to save about 18.75 ringgit per week. So which option more safe? Okay, so this option alternative are more safe after the 6,000 are recovered. Okay. So these are alternative that you can compare between the two options, alternative 1 and alternative 2. Okay, present system we have four average number of customer in the system is 4 customers. Alternative 1 is reduced by 1 to 150, 1.5 customer. Alternative 2 is reduced by 0.67. So it shows that alternative 2 give better option. Okay, this is how the operating characteristics are given in the form of graph from this table. Okay, you can also, based on this notes, you can also use Excel to calculate the operating characteristic given lambda and also mu. Okay, this one you can read on your own and try to understand it.